Okay, so as I explained last week, the first part of the chapter was a lot about reasoning and patterns and that sort of thing. The second half of the chapter focuses more on angles and using reasoning and logic with that. So today we're going to look at two types of angles, which we've really named already, and we've talked about their properties, but we're going to kind of talk about why it is today. So the first type of angle pairs we're going to talk about are called linear pairs. Again, we know what these are. They're two angles that form a line. So really the only proof for this is if I were to take a protractor and lay that protractor right on top of my my angle pair. So let's see if I can sketch in. Here would be our protractor that we would lay out. That's a really nice protractor there. Okay, so we'd lay our protractor out and we would know then that our angles are going to be like 120 and 60. Okay, so what we learned in chapter 1 was that if two angles form a linear pair, then their sum is 180 degrees. Or we could say they are supplementary. Again, we learned this in chapter 1. But we're just kind of talking about a little bit why today, and then we're going to keep building on this. Okay, so last week, in chapter 1, we talked about what vertical angles are. So we know if we have vertical angles, so let's draw a pair of vertical angles here. This one line. Okay, so if I have two intersecting lines, I actually create two sets of vertical angles. Okay, so I actually have two sets of vertical angles. We said angles 1 and angles 3 are vertical. Okay, and we said that angles 2 and angle 4 are vertical. Okay, and that's because they are the non-adjacent angles. Now, today, and we talked about too, a lot of you had already known that vertical angles are congruent. Okay, so we know that, for instance, angles 1 and 3 are congruent and angles 2 and 4 are congruent. Okay, so that's not really a big surprise. We know that they are congruent. What I want to talk about, though, is why. Oops, sorry, that should be a 2. It's congruent to angle 4. Okay, so you should have at your desk a piece of patty paper and a ruler. So I want you to take your pencil, your pen, and you're going to draw on this patty paper. Now, if you feel the patty paper, there's one side that's like really smooth and one side that's a little rougher. It's a little bit easier to draw on the rougher side. It doesn't matter if you do pen or pencil, but what I would like you to do is take your pen or pencil, and I want you to create yourself a set of vertical angles and make them fairly large. Okay, don't make it teeny tiny. I know some of you like to draw small. So we want a fairly large set of vertical angles here. And I want you to number them like I'm doing. So in a circle with the top one to be 1, go to the right, that would be 2, 3, and 4. Okay, so this is my patty paper here. There's my patty paper. Okay, so I want you to label it 1, 2, 3, and 4. Okay, so what I'm going to do first is kind of provide a visual proof of why the angles are congruent, or the fact that they are actually congruent. Okay, so what you're going to do is you're going to take your patty paper and we're going to fold this. Now, listen carefully how we're going to fold this. Keep in mind, I want to compare here angle 1 to angle 3. Those are the two angles I want to compare. So what I'm going to need to do is fold my patty paper so that the fold goes right through this vertex. Okay, and I want to lay the legs of angle 1. So here are the legs of angle 1. I want them to lie right on top of the legs to angle 3. Okay, so again, we're folding the paper. It may not be, like your paper may not be in half, and that's okay. It doesn't need to be. Okay, so you're going to fold it so that the legs of angle 1 lie on top of the legs of angle 3, and it should go right through this vertex. Okay, so what you should be noticing is that because the legs of angle 1 do actually land on top of the legs of angle 3, those two angles actually are the same measure, so they are congruent. And you can do the same thing with angles 2 and 4. Take the legs of angles 2 and fold it through this vertex and put it on top of the legs of angle 4. And again, you should see that they are actually congruent. Okay, so if you need to pause the video, go ahead and do that. If not, just let it roll here. So let's finish this conjecture. Remember, our conjectures are our educated guesses. Okay, so if two angles are vertical angles, then they are congruent. All right, so vertical angle conjecture. This is something that's really important to us throughout the whole year. The vertical angle conjecture, we actually use it so much that we shorten its name after this. We call it VAC, the vertical angle conjecture. Okay, so let's take a minute here and use some of our skills that we talked about with linear pairs and vertical angles. So I would always go vertical angles first. That's my favorite because I don't have to think. I don't have to do any calculations. I know vertical angles are always congruent. So I know if this is 125 degrees, then this must also be 125 degrees. Now, to find x and z, I can think about linear pairs. So I know this here is a linear pair, and we know linear pairs have to be 180 degrees. So if I take 180, subtract 125, I should get 55 degrees. So I know then that x and z have to be 55 degrees. Okay, so now what we're going to do is actually do a formal geometric proof of why vertical angles are congruent. Okay, so this is truly our first proof, and I'm kind of sad that I'm not here for it because it's a big monumental moment in geometry. But anytime we write a proof, this is kind of the information we're starting with. So first of all, I want to know what's given to us. What are we allowed to use? Okay, what's given to us? Then we have to think about what exactly is it we want to prove. Then we want to draw a figure. If it's one's not given to us, we're going to draw a figure of the given information. And then finally, we're going to make statements and reasons, kind of like the lawyer. Remember, we talked about the deductive reasoning to prove what we're trying to show. In our case, vertical angles. So if you recall, it says if two angles are vertical angles, then they are congruent. So this is called an if-then statement, and I think you've heard about this in science class. Okay, so if two angles are vertical angles, then they are congruent. The if part is typically what we're given. Okay, this is typically what we're given. So given, we have vertical angles. And we should probably be a little bit more specific. So I'm going to sketch a little picture up here. So there's vertical angles, and I'm going to name them 1, 2, 3, and 4. Okay, except really we can do away with 4. Let me just do 1, 2, and 3. Because I only really need to show one set of vertical angles. Because I can move those numbers around anywhere I want them. So we're given vertical angles 1 and 3. Okay, we want to prove that angle 1 is congruent to angle 3. That's the then part. So what we want to prove is the then part. Okay, so typically when we do a proof, a lot of times we just do 2-column proofs. They're typically the simplest and the most organized. You could also write this out in paragraph form. I hate those. I will never force you to do one of those, but if you want to, go ahead. So on the left, we make our statements. On the right, we put our reasons. Okay, now, our first statement should always, always, always be what we're given. Okay, so in our case, we're given vertical angles 1 and 3. Okay, so whatever is written up here in this given statement, right here in this given statement, whatever is written there, we literally just write here. And the reason we can write that is because, hey, it's given. We don't have to think too hard about that. Okay, now, we're trying to get to the fact that angles 1 and 3 are congruent. Okay, so let's think about 1 and 3 are congruent up here, but I also have a couple other angle pairs. I have this 1 and 2. I know something about those. Those are linear pairs. And I know something about 2 and 3. Those are linear pairs as well. Well, we already learned and proved with a protractor that angles 1 and 2 together should have to be 180 degrees. So the measure of angle 1 plus the measure of angle 2 should equal 180 degrees. And that was the linear pair conjecture. Okay, from here on out though, from here on out, I will write this as LP, linear pair conjecture. Okay, LP stands for linear pair. Okay, that's how often we use this, and I just don't want to keep writing it out. Okay, so we know angles 1 and 2 together equal 180 degrees. Well, I can make a similar statement about 2 and 3. So angle 2 plus, the measure of angle 2 plus the measure of angle 3 should equal 180 degrees as well. Again, because of the linear pair conjecture. All right, now, a lot of times what happens in these proofs, especially early on, notice that I have two statements here, but they both equal 180. So what I can do is go back and think about algebra 2 for a second and algebra 1. Like when you did systems of equations, remember how you had like y equals 3x plus 7 and y equals negative 2x minus 5? And because they were both equal to y, you ended up setting them equal to each other, right? You would end up saying, okay, well then 3x plus 7 has to equal 2x minus 5. Okay, well we have the exact same thing here, except this time they're both equal to 180 instead of y. But if they're both equal to 180, then they should both equal to each other. Okay, so that's what I'm going to write. I'm going to write the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle, that should have been 2. Measure of angle 2 plus the measure of angle 3. And what we did there is just called substitution. All right, now, think about our proof statement. We want to get 1 on the left and 3 on the right, which if we look at this last statement here, right now that we have so far, 1 is on the left and 3 is on the right, but we have this pesky angle 2. But think about if I have the same angle on both sides, I can get rid of that. I can just subtract it away. So if I use my subtraction property of equality, I can actually just take that angle 2 away. So the measure of angle 1 is actually going to be congruent. Let me back up, sorry. We're going to have angle 1. Your book skips a step. Like they automatically they take away the equals and start doing congruent. So they say angle 1 then is congruent to angle 3. And what allowed me to do that was the subtraction property of equality. And what I subtracted away was the measure of angle 2. All right, again, so if you need to pause this, and then you can make sure you have that proof written down because that's a good one. All right, I'm going to go ahead and have you take a look at this problem. Again, we're using just all our vertical angles and linear pairs and that sort of thing. So go ahead and find the measure of all those angles. Go ahead and write it in. We're going to give you a few seconds here to get that done. All right, hopefully you've had enough time. If not, pause the video. But let's start with up to the top here, A, B, and C. So again, I told you I like to do vertical angles first. So that's 70 degrees. So 70 and B are both have to be congruent. And then I have my linear pairs. So that means that each one of those has to be 110 because I know those two angles or any of the two angles there are going to be supplementary. Okay, I can use the same reasoning then on down here at D, E, and F. 60 and E are vertical angles, so that has to be 60 as well, which makes F and D 120 degrees each. Okay, last one then. We have 50 degrees here, so its vertical angle is H, so I know that has to be 50. Use my linear pairs, so if H is 50, then G has to be 130, and again, vertical angles, so I has to be 130. Okay, for your homework, you have 20 problems on this worksheet. You can write your work right on the paper itself. I know there's not a ton of room. Most of them you don't need a ton of room. I think, though, you can squeeze it all in. Tomorrow, we'll get the answers to those, and then tomorrow we'll talk about some more special angles.